All right, we're going to start percent of change today. So remember, percent of change, you defined this word the other day, is the difference in an original cost to a new cost. We're going to look at percent of increase, how much it goes up, percent of decrease, how much it goes down. So by the end of this, you will be able to use proportional relationships to solve percent of change problems. That's the whole thing. We did a whole unit on proportional relationships. Now we're going to use them to solve percent of change problems. Use estimation and reasoning to verify that percent of change between two quantities is reasonable, and use proportional reasoning to find the percent of change in real-world situations. So we use percent of change a lot in the real world. So let's do your warm-up. All right, so here are your 5 problems. Go ahead and pause your video and take about 5 minutes to complete those. Now that you've completed your problems, let's go over them. So there are 2 ways I could solve this. First, if I know 0.15 and is my decimal that I have to solve, multiplied by 100, because percent means per 100. I know that when I multiply by 100, I have to move my decimal place 2 points to the right, and so that is going to be 15%. So then if I have 0.9 times 100, all right, I'm still moving it 2 places to the right. If I do times 10, it's 1, times 100 is 2, times 1,000 is 3. It's how many zeros you have. And so if I move it once, I have to move it again. That means I have to add a 0. So 0.9 is 90%. I could also do it 0.07 times 100. I could also do it in our normal algorithm where we stack everything. Well, I know 0 and 0 are both just going to equal 0 for everything. So I'm going to go ahead and bring those down. So now 1 times 7 is 7, or 100 times 7 is 700. Then my other zeros. All right, so we left off at 0.07, 100 equals 700. Now I need to count my decimal points. 1, 2. So 1, 2. Put my decimal right there, which means that this is 7%. I'm going to do the same with my 0.33 times 100. Well, my zeros, everything's going to be 0. So 100 times 3 is 300. 100 times 30 is going to be 3,000, or 3,300. So then I add 1, 2 decimal points. So I go from my far right, 1, 2. So that is 33%. Gemma's proportion of correct answers on the test was 0.8. What percent of the answers did she get correct? So if we start with 0.8, multiply it by 100. So multiplying by 100 means I have to move my decimal point to the right 2 places. So 1, 2, I have to put a 0 in. That means it is 80%. All right, your vocabulary for this module, you should have completed those earlier this week. So your first word, percent of change, is a ratio that compares the change in a quantity to the original amount. It's going to be the amount of change over the original amount times 100. So an example, the cost of an item goes from $20 to $25. The amount of change is $5, which is 25% of the original amount, $20. So the percent of change is 25%. A non-example, the cost of the item doesn't change. Percent of decrease is a negative percent of change. So set up the same way, but it means that the price, so a jacket is on sale for $60, the percent of decrease is 20%. A non-example would be if the jacket had a price increase of $15 versus a price decrease of $15. 1% of increase is a positive percent of change. So, example, a $10 shirt has a price increase of $5. The percent of increase is 50%. So a t-shirt had a price decrease of 5%. So remember, a percent of increase, the original amount goes up. A percent of decrease, the original amount goes down. All right, so let's look at this. Percent of change. The cost of living increases over time. It just does. This is called inflation. In economics, inflation is the continual increase in the price of goods and services. This is why the cost of going to a movie seems to increase each year. Click on each ticket to reveal the cost of a ticket in 1985, 2000, and 2015. So let's click on the first one. In 1985, a ticket cost $3.55. In 2000, the average ticket was $5.39. And then by 2015, the average ticket was $8.17. So it says, how much did the ticket cost increase from 2000 to 2015? How does the amount of increase compare to the cost in 2000? All right, so in 2000, the ticket was $5.39. In 2015, it was $8.17. And it asked us to find that cost of change. So what I'm going to do is take my $8.17 and subtract my $5.39. And what do I have left? Well, 17 minus 9 is 8. 0 minus 3 I can't do, so 8 minus the 7. 10 minus 3 is 7. 7 minus 5 is a sloppy 2. All right, so the price increased $2.78. It says, what is the relationship between this cost of increase and the year 2000? So what am I going to do? I could divide, I could multiply. So let's see. If $2.78, let's multiply that by 2. See what gets that. So 8 times 2 is 16. 2 times 14, 15. 556. So it's not quite half. How do I know that that's half? Well, I know it's half because 2, if I divide something by 2. So it's not quite a 50% increase from 2000 to 2015. So that almost, so 50%, I took half of the cost and added it in those 5 years to the ticket. That's what we call a percent of increase. So this percent of increase is what we're going to explore today. So how can you use a percent to describe a change when a quantity increases or decreases? We're going to focus on increase today. So suppose a tent is on sale for $80. After the sale ends, the price increases to $96. By how much does the price increase? All right, so we're trying to figure out how much the price increased from the sale price to the normal price. So we have an $80 sale price and a $96 normal price. So I'm going to take the larger number, which is 96, and subtract the smaller number. So 96 minus 80, 6 minus 0 is 6, 8 minus 1 is 16. So the $16 is the price increase. So you'll go into your slides. By how much does this price increase? And double click in that and type in 16. All right. So how can I use a bar diagram to find a percent that corresponds to 16? We're going to move the pieces to divide the bar into equal sections. So what I know, the original price is $80. The new price is $96. And the price increase is by 16. So I know that we're looking at an $80 tent. And I know that the price increases by $16. I need to figure out how many groups of 16 are in 80. So I'm going to divide. Well, 16 into 80. This is where I'm going to get into a little bit of guess and check. What do I know? 6 times what gives me a 0? Well, 6 times 5. So let's try that. 6 times 5 is 30. Carry my 3. 5 times 1 is 5 plus 3 is 80. Hey, look, that worked. So I'm going to have 5 equal sections. So you need to move these boxes to put 5 on your timeline. So how can you use a bar diagram to find the percent? Well, we divided it into even pieces. I have it labeled that 100% of the bar was $80. 16% is 20%. Well, how did I figure out that 20? 80 divided by 16 is 5. The bar is divided into 1, 2, 3, 4, 5 equal sections. Each section represents $16. 100% divided by 5 is 20%. Each section represents 20%. So we know that it represents 20%. So what percent indicates the increase in price? So I have 20, 40, 60, 80, 120. The 120%, because I had to add an extra 20 to get to my $96. So that'd be 120%. Percent of increase is when the original amount is increased. Remember that. All right, so we're going to do another problem here. The price of a monthly internet plan increases from $36 to $45. You can use a bar diagram to determine the percent of increase. By how much does the price increase? All right, so we know we have a $45 new cost on $36 old cost. So I'm going to go ahead and do my subtraction of 45 minus 36. I always have to subtract the smaller number. So 5 minus 6 I can't do. 4 becomes 3. 15 minus 6 is 9. 3 minus 3 is 0. So my increase is a $9 increase. All right, so how much does it increase? So in this box, you're going to type $9. So our next problem says, use the bar to represent the original price of $36. Because the original price is the whole, label the length of the bar 100%. So that's already labeled for you. Fill in the highlighted price increase. Split the bar into equal pieces. So what am I going to do? Well, let's see. Let's see if I can just move pieces in to figure this out. So we've got 1, 2, 3, 4. Pardon my inappropriate lining up, therefore. All right, so 36, if I have 4 pieces there, you know what, that makes sense. 36 divided by 4 is 9. So the price increased by $9. Oops, that ran out of space, didn't it? $9. So we have 4 pieces. Uh-oh, how much is that going to be? What's 100 divided by 4? So 100 divided by 4, let's look at our next tile here. So we know, again, the price increased by $9. We know that. We know that this one is going to be $9 because 36, we already said that one price increase and that there were 4 pieces. So 100 divided by 4 is going to be 25. Oops, I got a whole bunch of extra pieces in here. It's going to be 25%. Because 25%, then we have 50%, we have 100% or 75%, then 100%. So what does that mean? This price here, so 36 divided by 9 is 4. The bar is divided into 4 equal sections. Each represents 25, or each represents $9. Cool. 100 is divided by 4. How many sections we have is 25. That's your 25%. Each section represents 25%. Cool. So now we're going to look at this last part here. How much is it going to cost? Well, 36 plus 9 is going to be 45. 100 plus 25 is 125. So the total cost of the bill is going to be 125%. So your exit ticket for class is to solve this problem. Frankie calculated that she would need 9.5 yards of wallpaper to decorate her room. The wallpaper she chose had a large pattern, so instead she needed 13 yards of that paper. What is the percent of increase rounded to the nearest percent in the amount of wallpaper she needed? Show your work, take a picture, use text, type your answer there. Then your homework is going to be this Google form. It will be assigned in Google Classroom. There are 7 questions and a bonus question.